Okay, this is about the pre-processes for the Grims model. Grims model's input data set is first it's a sigma layer data and it's a spectral coefficient. So this pre-processes handles two steps. The first thing is converting the vertical layers from the pressure to the sigma, and the second step is performs the space transforms from the grid space to the spectral space. Okay, that is the what this to the p2sig, the these processes do. Okay, so first we have to download the p2sig package, but the p2sig package itself is exactly the same to the global models package. So let's just start to get the global models packages. So first it's a global library. Okay, here we have, and the next for the source code. Okay, now we have the source directory, and the third one, the last one is run script for the global. Okay, so let's just start from the libraries. Okay, so here the if you have some more details about installing the libraries and source code, maybe you can refer the another tutorial clips for the how to install the regional model system or the global model system. So I set the Linux system and using the Intel Fortran compilers and using the MPI processes. Actually, these pre-processes is usually the input-output processes. We call this I/O. The I/O process is fundamentally using the single cores, but there is some calculations also can be handled by the multiprocessors. So if just still you can choose this one for the single or the MPI, but here I just set to the MPI and configure it and make. Okay, the library setup is done, and let's move to the source code. Okay, in the source code we have to specify these library directories. So I move back and I'll copy this path and move back to the source and modify the configure source script here. Okay, so first replace this rips directory and this model part. So this is fundamentally the global models setup. So we just for the these p2sig process, you can just put this model part for the SVH. This is the global models component, which uses the spectral harmonics. Okay, the version is actually doesn't matter for these processes, but just put stay in the version 3.2 and set marches MPI, just because I set the marches in the library as for the MPI. Okay, so it's done. So let's do the configure source. All right. So now we have to consider one thing. Um, Before compiling, after the configuring, and before the compile. At this stage, we have to decide one thing. It is about this option. It's about define hybrid. Okay. This is about the hybrid sigma pressure, the vertical coordinate. So if you are want to the basic thing is after the p2sig we will have the data in the sigma layers, but still we have the options for with this hybrid option. If the hybrid is defined, the sigma layer is the output. The sigma layer is hybrid sigma pressure layer, but if we turned off this hybrid option, then the result itself is the pure sigma layers. If you are tending to use the global model, it doesn't matter, but just for you are doing these processes for regional model, still the Grimm's regional model part only have the pure sigma vertical coordinate, not for the hybrid coordinate. So if you want do this process for the regional model program, the RMP, then turn off this hybrid option by replace the define to the undefined. Okay, this is quite important things. So please remember and changing these options to fit your purpose. Okay. After turned off the hybrid, because this is one example for the maybe just think this is the examples for the making the boundary conditions for the RMP. So now let's do the make. Okay, so now the compile is done. So let's now move to the boundary trace. So at this stage, let's think about the input data set for the p2sig. So the p2sig process means just input for the p2sig is the pressure and grid data set. And one more thing is this p2sig processes require the grip 1 format. So the things are the input for the p2sig is grip 1 dataset and pressure level dataset and grid space dataset. Okay. So for this, I prepared some dataset here. So one example for this p2sig example, I prepared the NSET final analysis dataset. Okay, so this is it. But as you can see, this final analysis is presented by the format of the grip 2. So before we running the p2sig, we have to convert this grip 2 dataset to the grip 1 data format. Okay, you can simply search in the website. Maybe you can. There is not a only way to converting the grip 2 into the grip 1. One way is the CMV grip, the converting the grip. This is provided by the NSET. So I'm gonna use the CMV grip. But if you have the CDO, maybe the CDO is also another tool can convert the grip 2 format to the grip 1 format. So this is how I use the CMV grip. So first its usage is CMV grip. The option is grip 2 into the 1, and grip 2 in input grip file, this is grip 2, and output grip file, this is grip 1, like this way. Okay. With some time, so it's done. Okay, so now we can see here the grip 1 data is created. Okay, so in the same way you can repeat this process for the entire other data set, or if you have like too much data sets for like some years or some decades or the 100 years, maybe doing this work in this by every type is not an efficient way. So if you have so many files to convert from the grip format, I recommend just make some shell script for this process. Okay, now so the dataset is converted from the grip 2 into the grip 1. Let's check the result. Okay, so all these are now changed to the grip 1 dataset. Okay, so to avoid some confusing, and make another directory for the grip 1, and I move to the grip 1 dataset to the grip 1 directory. Okay, now so in the grip 1 directory, now I have the old converted grip 1 formats here. Okay, now I'm ready for the grip dataset. And one more thing, for the surface dataset, the p2sig processes requires some kind of the surface external surface dataset, not from the in this case not from the FNL, because p2sig requires the external surface dataset. So in current code structures, the NCEP DOE, the RA2, the surface real analysis data set, which in the form of the IEEE format, this is the this might be the best options for the p2sig processes. So the recommendation is the first date of the model run, just prepare this surface dot analysis dot the years, date numbers, and IEEE. This format recommend to prepare this data set before the p2sig. Okay. Now let's move to the p2sig install directory. Okay. We need this path for the grip 1 data, so I just copied. And now let's move into the runs GMP. Let's see the configure run. The source directory is source GMP in the upper level. And here, okay, so here the wave means the resolution of the output of p2sig. So here I will use the T62. So this wave means the output resolutions of the p2sig. And this model layer is also the output resolutions in the vertical direction. So I just set this to the 28. Here the p2sig process is doesn't require the post processes, so this post I grid or post J grid is not important here, and also the first layers is not affectable. Okay, this is for the original model, so we can skip. And this is for the input for the surface and spectral wave. Just one thing here. We just brought the surface files from the reanalysis too. So, and in the resolution of the T62, right? So I just set the same numbers for the T62 here. Okay. All right. And this is few numbers. This is actually this is not important, but anyway, I just change it because I'm gonna use the single process for this p2sig the preprocessing. So actually, that numbers are not that much important here. Okay, so after the modifying the configure run script, now we make some p2sig the run script. The name of the p2sig run script is gmt p2sig. Okay. So now we can see the gmt p2sig is prepared. Okay, so the first part we have to specify is pressure. This PRS type means the pressure level data type. So there's presets for the FNL, the reanalysis 2, or the ECMWF, or the ECOM, or the headgem. In our case, it's the FNL, right? And this is the directory for the input pressure files, right? So in our case, this the directory for the converted grid 1 data is stored is now we can specify here, and here the initial surface file. Let's go back to the directories for the initial surface file. It was here, okay? So just scrap this. So if you have, absolutely you will have this dataset in different paths. So please make sure you set the right path for your system. Okay. Doing the GMP p2sig. So this is the initial file. So these files, the path is up to the file name. So I'm just changing to the path here. Okay, and the starting and ending date. What I prepared is 2010 July day 1 to the day 3, July 1st to July 3rd. Okay, so this is the our name. So the PRS type was FNL, right here. Our setup was FNL. So this run script will create the output directory with the name of the FNL sig. Right. So here is the p2sig setup. So for example, our setup, if DLC for the pressure data type is FNL, like specific humidity 1 for the relative humidity, 0 for the specific humidity, or something like that. If you are using one list from this preset part, so maybe you don't need to worry about to modify this part. But if you are if you want some other data set which is not specified in this run script, then you can make your own this name list for your new input data. Okay. So even they're specified to not edit below, but there's one more thing we have to edit. That is the here. Please make sure this pressure pile name itself is exactly the same, because this is kind of the typical output name for the final analysis. But in our case, because we converted files, so and we created the name, so we have to modify the names for the actually the names for the files we actually have. Okay, so we change this. Okay. Okay, so now let's run the GMP p2sig. Okay, it's done. So now we can see this directory is created, the p2sig, and we saw this is the alpha directory name specified in the GMP p2sig run script. So now this is the output. The surface analysis is the date and IEEE, and sigma analysis date and IEEE from 2010 July 1st to the July 3rd. Okay, so this is very brief instructions for how to make these IEEE files, which can be used for the input data for the CRIMS. Okay, so